Okay. During the last session, what we have discussed is about the projection of lines inclined to both the planes using the plane rotation procedure. So only just one problem we have discussed, and today we will discuss 2 or 3 additional problems. Last problem that we discussed on plane rotation method was somewhat difficult. Difficult in the sense the one of the point was in not in the first quadrant; it was in some other quadrant. So that problem was done in order to make you understand that such problems are some of such problems are difficult to do in a line rotation procedure, but maybe easy to do it in a plane rotation procedure. Today we will see some of the simpler problems in engineering graphics which is solved using the plane rotation procedure. One of these problems that we consider today, we have already solved such sort of a problem using the line rotation procedure also. Then once you have completed it, you can compare it with the one which we used, the problem which we used this line rotation procedure, and how the drawings differ, and does it actually differ? We are not using the same question, somewhat different in the sense only the dimensions are slightly different. Okay. So this is the question. Almost a similar question we have done, not almost a similar question we have done as our first exercise in projection of lines inclined to both the planes. The question is, a line AB has its end A 10 millimeter above HP and 15 millimeter in front of VP. The other end B is 35 millimeter above HP and 45 millimeter in front of VP. The distance between the end projectors is 60 millimeter. Draw its projections. Also find the true length and the true inclinations of the line with the HP and VP. Also locate the traces. The same problem with a slightly different dimensions or slightly different data we have solved as our first exercise in projection of lines inclined to both the planes. So in that case, we used the line rotation procedure. In this case, here we will use the plane rotation procedure. Okay, just to note down the question. Okay, now let's move on to the solution. So this is our base figure. In this one, the data that are given is the end A is 10 millimeter above HP, that is this distance. The A dash is 10 millimeter above the XY line. So this is 10 and 15 millimeter in front of VP. That means the point A is 15 millimeter below XY line. So this is 50. And the other end B is 35 millimeter above HP. So this is 35 millimeter and 45 millimeter in front of VP. So this is 45 millimeter. So then the distance between the end projectors, that is this distance is given as 60 millimeter. So these are the data that are given. This problem with this different data, with a set of different data we have already done. So this is 45, 5 is not similar, 45. Okay. Now, as usual, we start with an XY line, then we draw the projections. First, we draw the point A dash. Point A dash is 10 millimeter above XY line. And then we mark the point A, which is 15 millimeter below XY line. Then 60 millimeter, distance of 60 millimeter from this projector, that is the projector for A and A dash. We draw another projector, which is the projector for B and B dash. So in that projector, we mark the point B dash, which is 35 millimeter above the XY line. Then we mark the point B, which is 45 millimeter below the XY line. So once this much is completed, you can join A dash with B dash which is the front view, and then the point A and B can be joined so that you will obtain the top view. This much is very simple. Now what to do is, now in order to find out the true length as well as the true inclinations, what we have to do is we have to draw perpendicular lines from A dash as well as B dash, perpendicular lines from A dash as well as B dash, and the line should be perpendicular to A dash B dash line, that is the front view, like this line. This line is actually perpendicular to this front view. So likewise, we also have to draw two perpendicular lines from A dash and B dash, which are perpendicular to A dash B dash line. So one is like this, and the distance of this particular line, the distance of this line should be equal to the distance of this line, that is the distance of A from XY, that is in this case it is 15 millimeter. So that is, we have already mentioned that this distance should be equal to this distance. So that is the 15 millimeter distance. Here it is 15 millimeter. So the length of this A dash A1 line should be 15 millimeter. 15 millimeter. 15 is obtained from this line, this length. So that 15 millimeter you have to draw, and this line should be perpendicular to this A dash B dash line. Now another line which is perpendicular to A dash B dash and passing through B dash. So here this distance should be equal to this 45 millimeter. Why 45 millimeter? Because it is the distance of point B from XY line. So this particular 45 millimeter is to be repeated here. So this is 15 and this is 45. And 15 is the distance of point A, that is the top view of A from the XY line, and the distance of B is our distance of B1 from B dash is the distance of B from XY line, that is 45 millimeter here. Now you can join A1 with the B1, and this will give you the true length. So finding the true length is here. Finding the true length is very easy. Just what you have to do is there are no arcs are involved. You don't have to use your compass at all. What you have to do is you have to use your protractor to draw two perpendicular lines from A dash and one from B dash, and the distance of this particular perpendicular lines that you mark using your scale, the distance should be 15 as well as 45, and then join those 2 points A1 as well as B1. So this is the true length. Now in order to find the true length in the top view, if you want to find the true length, you need to find the true length because you have to locate the traces. So you need the true length line in top view also. For that one, you draw perpendicular lines from A as well as B, and the length of the line, this A2 length should be equal to the distance of A dash from XY line, that is 10 millimeter. The distance of A dash from XY line, which is 10 millimeter, that is to be marked here, A2. And from B, the perpendicular line of length which should be equal to the distance of B dash from XY line, that is here it is 35 millimeter, that is to be marked. So B2 is equal to 35 millimeter. So that 2 points you got, A2 as well as B2, join A2 and B2. So this is also true length. If both the lengths are same, equal, when you measure, it is perfect. A slight variation of 1 millimeter or 2 millimeter is also acceptable, but more than that, that is a 5 millimeter difference, that cannot be accepted. So this is the simple procedure by which you have to draw only perpendicular lines to the front view as well as the top view in order to obtain the true length lines. Now to get the HT and the VT, so you extend the line A1B1, you extend the line A1B1 such that it can intersect with the extension of the front view, that is A dash B dash. So you extend the A1B1 towards this side. In this case, it is towards the left side. In some cases, it could be towards the right side also, where the distance between A dash and the true length line as well as the front view line is minimum. you have to extend the line towards that side. Then only you will get an intersection of both the lines. So A1, B1 is extended towards the left, and likewise A dash, B dash is also extended. And the point of intersection of these two lines gives you the VT, the vertical trace, like this. Here, see. Here the front view line is front view, A dash, B dash is extended, as well as A1, B1 is extended. The point of intersection of both these points will give you the VT. V doesn't need V. The point of V is not required here, so we are not going to find out the point of V. Instead, we are limited to only VT. So now VT is obtained, and now the inclination or the angle in between these two lines, the angle formed at VT is the phi angle, that is the inclination, the true inclination with the VP, this angle. The true inclination with the VP can be obtained as the angle included at the point VT. So this is simple procedure by which you can obtain the VT as well as the true inclination with the VP. Now in the top view also, you extend the true length line as well as the top view so that they intersect at HT. In this case, they intersect at HTC. Here, the top view line is AB, so AB is extended, and A2, B2 is also extended. Both lines intersect at HT. So this point is HT, and the inclination, the inclination with the HP, the true inclination with HP, theta can be obtained as the included angle at HT. So this angle is theta. So that's it. And then if any dimensions are missing, that also you have to mark. Here you have to mark the alpha. Alpha is the inclination of the front view with the XY line. So that alpha is to be marked, then beta is also to be marked. So beta is the inclination of AB, that is the top view with the XY line. So alpha and beta are marked, theta and phi are marked, and all the other dimensions we have already marked. And that's it. Then you have to complete this drawing, this rectangle, in which we write the true length, theta, phi, then alpha as well as beta. So this is the procedure. I will explain once more. Drawing the projections, that is easy. First you draw XY, then 10 millimeter above XY line you mark A dash, 15 millimeter below you mark a point A, at a distance of 60 millimeter from the projector for A and A dash, mark the projector for B and B dash, and on this particular projector 35 millimeter above XY line mark B dash, 45 millimeter below XY mark B, join A dash B dash, join AB. Now from point A dash as well as B dash, draw perpendicular lines in order to obtain A1 as well as B1. Join A1 B1, which will give you the true length. Similarly, from point A as well as point B, draw perpendicular lines in order to get A2 and B2. Join A2 and B2, this is also the true length. Now extend the true length line in the front view as well as extend the front view. The point of intersection of both these extensions will give you the VT, and the included angle will be phi. Now extend the true length line in the top view and extend the top view. The point of intersection of both these extensions will give you the HT, the horizontal trace, and the included angle will give you the theta. Then mark the inclination of the front view with XY line and the inclination of the top view with the XY line. So alpha as well as beta. Now finally complete it. That is it. I hope this is simpler than using our line rotation procedure. Now we can draw it in open board. 10, 15, 35, 60. So this is our base figure, and the the values that are required. Here it is 10, here it is 15, here it is 35, here it is 45, and the distance between and projectors, this is 60. Now we take our scale to draw the XY line. So this is our XY line. XY line. Now we mark the point A dash as well as A. So in order to mark it, we draw a projector, a perpendicular line. And on this particular line, you have to mark your 10 millimeter above the XY line as well as 15 millimeter below the XY line. So here is point A dash and A dash. This is point A. Now at a 60 millimeter from this line, draw another line. 60 millimeter from this line, draw another line. And so on this line, mark a 15 millimeter. Sorry, not 15, it is 35 millimeter. $35 above as well as 45 millimeter below the XY line. So this is point B, and 35 millimeter above the XY line, we mark point B dash. So now you can join B as well as B dash using a straight line. A dash and B dash, and A and B. So this is point B dash. This point B. So this much you have obtained. Now what we have to do is you have to draw perpendicular lines from from A dash as well as B dash. So in order to draw perpendicular lines, you have to use your protractor. So first point and the second point. So now on these two lines, on these 2 points, you have to draw a 15. So this is 15, so 15 millimeter line as well as here. A 15 millimeter straight line. So that is point A1, and here it should be 45 millimeter. So this is point B1. So here it is point A1, and here is point B1. Now you can join these 2 points. I'm joining it using an extended line instead of drawing the extension. Again, I am just extending the line. So this is the extension in which we will obtain VT, that we will do further. But in the initial case itself, we can extend it. Now we draw perpendicular lines from this point, that is point A. Here is and point B. Point A as well as point B. Now with these 2 lines, draw the perpendicular lines. So here the distance should be the distance of A dash from XY. A dash from XY is 10 millimeter. So here we are marking only 10 millimeter. And here you have to mark it as 35 millimeter. Here it is 35 millimeter. Now these 2 points are A2 and point B2. Now join point A2 with B2 and extend the line. Extend the line. Now what I need to do is this A1 B1 is the true length as well as A2 B2 is the true length. Now what I need to do is I need to find out HT as well as VT. Now to find out VT, what I need is A dash B dash should be extended. In order to extend A dash B dash, take the scale and make it coincide with this AB line and then extend it such that it intersects with our line which is through A1 B1. So that is the point Vt. So this is the point Vt. This point Vt, and this inclination. This inclination is phi. And now in order to find HT, we need to extend the top view, again using the same procedure. Using the same procedure, you can obtain the point HT also. Here is point HT. This is the point HT, and theta is the angle. Theta is this angle. This angle is theta. So that's it. So first you have to mark the both end projectors, then point A dash, point A, point B dash, point B. The dimensions also you should mark. I have it marked the dimensions in this figure, but you have to do it in your figure. Then from A dash as well as B dash drop two perpendicular lines, and on these lines the distances of A and B, that is the top view of A and B from XY line is marked. Top view of A and B from XY line, the distance of a top view of A and B from XY line is marked on these perpendicular lines, and those 2 points we obtained. The points that we obtained thus is the points A1 and B1. So the distance A1 and B1 will give you the true length. Then extend, another two perpendiculars from A and B, that is the top view of capital A and capital B, that is small letter A and small letter B are drawn, and the distances marked are the distance of A dash and B dash line, that is these two distance, this distance from here. The distance from this point, this to this, that is the distance of A dash from XY line, that is marked, and the distance of B dash from XY line is marked through the projector through B, and then we obtain points A2 and B2. Then point A2 and B2 are joined, and this is also giving you the true length. So two true lengths are obtained here, A1 B1 as well as A2 B2. Now extend A1 B1 and A dash B dash such that they intersect at a point VT, that is the vertical trace, and the included angle is phi, the true inclination with the VT. Then we extend the lines A2 B2 and A and B so that they intersect at a point HT, and the included angle is theta, the true inclination with the HP. So that's it. So this is the drawing, and to finalize the drawing, you have to give the dimensions also, as well as the alpha value. The alpha value is to be given, as well as beta value is also to be found out. So here is the alpha. This is alpha, and here this value is beta. So this also you have to mark, and that's it.